Hello there, this is James, and we're going to do the presentation today on the lactic acid system, and this is specifically for the AQA A2 Physical Education specification, and this video was recorded in 2013 in case there are any subsequent changes to the specification. So first of all, we have to remember that all of our energy systems, and you'll have seen in our previous videos, all of them have one core aim, and that aim is to resynthesize, and you know what's coming next, of course, resynthesize ATP. So that is the job of our lactic acid system. So let's sort of start working through this. If we start our start point is always and absolutely never changes what is our fuel source. And in the case of the lactic acid system, our fuel source is glycogen. Now, you should remember from previous videos that our glycogen, I'll write it over here, can be stored in two places. One is in the liver, and that's where our primary store is, and the other is in the muscle, or indeed, the muscle cell, or indeed the cells of the body, but we're interested in the muscle cells from the perspective of physical education. So first of all, what do we do with this glycogen? In fact, even before then, let's realise that this glycogen, it exists, and this process is going to take place once again, just as with the PC system, within the sarcoplasm of the muscle cell. So first of all, we break down our glycogen, and we do this through a process of glycolysis, and through that quite complicated process and far beyond the reaches of our A2 AQAP specification, so I'm not going to go into too much detail, as we break down our glycogen, we produce a product called glucose 6-phosphate. Now then, you simply need to refer to this as glucose, but of course what I'm hoping is the case that you see the idea of 6-phosphate and you think, well, presumably that is the phosphate which is going to be used to reattach phosphagen to ADP to make ATP, and you would be absolutely correct. But from this glucose 6-phosphate, what we must do next is we must convert into a product called, I'll write it in here, pyruvic acid. Now, pyruvic acid we can take through a number of processes, but what I want you to realise first of all is that in this breakdown of glucose into pyruvic acid, we are able to resynthesize 2 ATP, and that is rather exciting because those 2 ATP of course demonstrate that we are utilising glycogen to resynthesize ATP. Now then, a couple of things before we go any further. I want you to realise that we have a couple of enzymes involved in these reactions. First of all, if we look at, there are lots of enzymes involved in glycolysis, but the one we can get credit for and get a mark for is that there is a controlling enzyme called glucose, good word this one, quite long, phosphorylase. And we also, that's sometimes referred to as GPP, G from here, P from here, and P from here, glucose phosphorylase. Now then, you also need to be aware of that in the breakdown of glucose into pyruvate or into pyruvic acid, we utilise an enzyme called PFK, and this enzyme is referred to, or its name is phospho, I'm going to do a capital in the middle of a word here, which is unusual, fructo, and then a capital here, kinase. And this enzyme, if we just underline a couple of things, we have phospho with P, fructo with F, kinase with K, and of course you can refer to this enzyme as PFK, which of course is our controlling enzyme. Now then, let's get back on with this. We have our pyruvic acid, we've resynthesized 2 ATP. Well, what happens now? Well, first of all, if there is sufficient oxygen present, we can continue the breakdown of glycogen aerobically. But we're going to argue, for this purpose, of course, we're looking at the lactic acid system, we do not have sufficient oxygen. So therefore, we are going to bring our pyruvic acid over here, and we are going to convert it into something which you will recognise called lactic acid. And of course it's this lactic acid which is a fatiguing byproduct of this reaction. So we are saying that this is happening because we have insufficient O2. I'm just going to make that really simple. I'm going to say no O2. That's quite an exaggeration. But we've got to say really insufficient O2. Pyruvate converts to lactic acid, and this product here becomes a product which we must remove or we must convert. So we start with glycogen, we break it down into glucose in the presence of GPP, and then in the presence of PFK or phosphofructokinase, we break down into pyruvate or pyruvic acid. In that process, we produce 2 ATP. So let's try and summarize this system as we've done in previous videos. Let's look at our advantages. So our advantages. Well, first of all, we can say that this is high intensity energy, just like we did for the PC system. So it's high intensity energy. And we can also say, secondly, there is no delay for O2 delivery. So once again, no delay for O2 delivery. But there are some disadvantages. And we'll put those in over here. Once again, as I finish writing this word, once again, we can say that our disadvantages are, one, that this system is short duration. You will know from your experiences, but also think about sort of athletic events, that this short duration can be up to around about a minute in duration. And really, if you think about something like a 400-meter race, the faster we go, or the more energy, or the higher intensity energy, the shorter that duration becomes. So anything between 10 seconds and a minute typically is powered by the lactic acid system. Secondly, we have a fatiguing byproduct, and that fatiguing byproduct, of course, is lactic acid. And thirdly, we would also say that this system, similar to the PC system, is inefficient, and the energy yield is 1 to 2. If we go back to our process here, we're saying the fuel source, let's just highlight these things. Our fuel source is glycogen. The site of reaction is the sarcoplasm. The controlling enzyme is PFK, phosphofructokinase, and of course we have 1 glycogen for 2 ATP, so our energy yield is 1 to 2. But don't forget, we also have a fatiguing byproduct in lactic acid. Thank you for listening, and good luck with your studies.